Okay, so today it's going to be a short class. I gave you a bunch of work the last class, so I'm going to let you get to those labs or this program quickly. Today we're going to talk about blind SQL injection, which is just another class of SQL injections, but its effect is much more devastating, I think, because of what it can infer. This is your first programming assignment. You'll be writing a program to basically implement a blind SQL injection attack on one of your homework, one of the Web for Pen Tester levels. So to talk about the homework, I want to go back to the schedule just to get everyone situated. So I am going to assign it here. This is the end of the third week. I'm going to give you 2 weekends to do it. So hopefully you give it a shot this weekend, and if you are really lost, you get help next week. Because I am going to have the blind SQL program in the lab notebook number 2 due the following Monday. Okay, so there will be one more set of labs as well next week, but that's the outlook. So you have the labs that I assigned last class. You'll have a smallish set of labs next week on authentication, and then you'll have your blind SQL program. So I would try and get the bulk of that as much as you can this weekend, and then get help the following week. Yeah.
Those additional labs will just be part of lab notebook 2 turned in.
Yeah. 5. Yeah. So 2.3 I'll assign next.
Oh, right. I see.
Yeah. There's only one more set of labs, 2.3, and they relate to authentication. So I'll be doing authentication all next week. And then ways of breaking it would be lab 2.3. Okay, so that's the roadmap. So blind SQL injection. This is basically a SQL injection attack that tricks the database into revealing information that the adversary is interested in. And the way it does it is by inferring a side channel, by inferring information via a side channel, and by submitting queries that allow it to determine states of database entries based on this channel. Oh, yeah. Okay, so one famous side channel, which we'll talk about in authentication, is the side channel that allows you to figure out if a username is valid by just typing in the username, hitting next, and having the interface tell you whether or not that user exists. Now, typically when you do authentication, you say username and password, submit both, and I'll tell you if that thing is valid. In that way, you don't know which one was wrong, the username or the password. But if you allow just the username and you click, next, and then type in the password, and it tells you that that user doesn't exist, that is actually a way of enumerating users on a target machine. So you would never do that anymore. The same thing with blind SQL injection. When you have queries that you send into the database, it should never be possible for you to reveal something about that query. Okay, so blind SQL injection is basically a game of 20 questions, and we'll talk about what those 20 questions might be. An example of this is one of the things that you can inject into SQL statements is the sleep command directive. And so you can, and with SQL, there's also conditionals that are supported. So with conditionals, you can check for certain database state and then issue the sleep command if a certain state holds. Okay, so these are primitives in your programming language that you're like, wow, I can build all sorts of things with conditionals. Well, you can do all sorts of things on a back-end database when you have conditionals that you can check on that back-end database against. Okay, so typically the blind SQL injection attack relies upon things like MySQL's like operator and regex operator, so regular expressions that you might have come across already in CS. You're going to be checking things against the like or the regular expression thing just to test, what is this password like? And then it's going to say, oh, it's like this or it's like that. And then you're going to be like, oh, cool. Let me ask you another question. Does your password begin with an A? Like, yes or no? B, yes or no? That's the game we're going to play with Blind SQL. Every language is different. So depending on the database that you come across, you might use different primitives. So if it's a SQL database, SQL has defined operators you can inject into that backend database. MongoDB is SQL-like. It's got a different thing for implementing regex. It's got this match function. And with the match function, you can supply a regular expression to say, does this match? The thing that I'm checking for doesn't match a particular value. This is what you're going to do for your homework. Use MongoDB. Okay, so just some primitives, if, like, and sleep, if you come across these. If you have a backend that is implemented in SQL and it's injectable, then you would use these primitives. So the if in SQL is just like in a programming language, test to find out if something is true. And then it's defined in parentheses. You have the condition that you define, the true outcome, what do you want the SQL backend to do if that condition holds, and then what would happen if it's false. There is also the like operator that is used. It's basically a poor man's regular expression, or poor person's regular expression. I don't want to be chauvinistic. It's a like is it's got a percent character which matches 0 more characters, or the underscore character which matches exactly 1 character. If you want to look at patterns in the data that you're querying, then you would use the percent and the underscore. Sleep just pauses the program or the backend for a specified number of seconds. So if you have something that looks like this, you can inject. So if you have an injectable form, like a SQL, if you have an HTML form that takes your parameters and feeds it into a SQL statement that is injectable, then you can inject a predicate like this. If the password column for that user is like this string, sleep for 5 seconds, otherwise do nothing. So this is testing whether or not the user that you're querying against, so say the form takes a user field, it's querying if that user has a password that is P4SSW0RD, and then it will sleep for 5 seconds if so. Okay? So you can sort of see that that's not something you actually want to have happen, someone to be able to do that query, and that's why this is a pretty substantial vulnerability. SQL also has the regex keyword, so any kind of regular expression. It's very similar to like, so for those of you who are familiar with regular expressions, what does this statement do? If your password regex, and then in quotes, this is your regular expression, hat, square bracket, A to Z. What does that mean? Yes? Yep, if the password starts with a lowercase alphabetical character, I'm going to do something. So, so this is true if the password begins with a lowercase character. And then you would use this in conjunction with sleep to probe the correctness of your regex, basically. So what does this statement do? And password regex hat foo and sleep 5. What would this do for regex folks? Yes. Yes. So I should repeat the question. The answer was see whether or not this password starts with foo. So if the password is foobar, then yes, this is true. Or if it's just foo, this is true. It will sleep 5 seconds. So this means, so the hat, in regular expressions, the hat means starts with, the dollar means ends with. And then the square brackets are saying, I want to specify the characters that it will match against. So this will match 1 character in between A to Z, is in the top one. And then without the square brackets, you're trying to match characters exactly. And then there's a star operator, a star and a plus for matching arbitrary numbers of characters, or a question mark for a single one. These are regular expressions that you can use in these statements. Okay, so quite powerful. Okay, so if the password begins with foo, pause 5 seconds is what that predicate turns into. I'm attaching this to a, so say I have a user form, and I'm trying to figure out that user's password. And so if that select statement has selected the username and password column, then I also have this I can use within that query. So that's sort of like if you do a select star on users, typically there would be a password column, and then you would say, you know, get the row where the user is, whatever's in the form, and then password. But that's a good question. Yeah, that's the reason the and is there. Okay. Okay, so here's another one. This is related to the union operator that we talked about earlier. Say you want to figure out the number of columns a particular query is that you're injecting into has, like the table that you're trying to inject, the table you're trying to attack where the SQL statement is doing the select from. Say you want to use a union operator to union a result to it, but you have to figure out, well, how many columns does that thing have? You could do something that looks like this, using the count predicate that says count the number of things that are returned. So in this case, if a select count from information schema.columns, where table name is users, is like, say, 5, then what this is going to do is it's going to get the number of rows in the columns table for the table users. And it turns out the number of rows is the number of columns in that table, because you have you've asked for the columns that fit that table. And then you sleep 5 seconds. So this is another way you can figure out how many columns exist on a particular table you're interested in. So other questions about that predicate, in case you come across it? Okay, so now we have something that we can build a blind SQL injection attack upon. So here is a query that we are able to inject because the username is injectable. So in the backend form, it's building this string, select password and isadmin from users, where username is equal to what to something. So this was done in the last class. This is the same query. So I'm going to specify that my username is Bob, and then break the syntax with that single quote. And then I'm going to attach this predicate. If the password column is like binary, and then in this case, the like with the percent means that the password has a single character. Okay, so it's trying to see, so this should always be true, unless they allow null passwords. So this should always match, right? Like if it's like percent, sleep 5. And so you send this into that vulnerable form from last class, and what should happen is this should sleep 5 seconds, because this predicate matches. Okay? Then you say, okay, what about this? I have a percent. So this means the first character is a, followed by any other character. 0 or more other characters is the percent. And of course, this is, you get a very quick response. So immediately here, you know that this person, Bob's password, doesn't begin with an A. And then you can keep on going sequentially through all the characters in the alphabet. You try B, and B is fast. You try C. C is fast, D is fast, and then you get to a character P, and P% gives you a 5-second response time. So then you know Bob's password begins with a P. Okay? So once you know that, you can go on to the next character in Bob's password. And that's what we're going to do now. We know Bob's password is P. So then we'll do PA%. Okay? PA% takes 0.2 seconds, so the second character is not A. And then we keep on going. PB is a fast response. PC is a fast response. And then we get to P4, and P4 takes 5 seconds to be returned. So now we know the second character. So we know Bob's password starts with P and then a 4. And we can go sequentially through all the characters. And let's say we're getting towards the end. And P4, this password with a % sleeps 5 seconds. So we're like, okay, let me do password with an A. And then this is a fast response. Password with a B is a fast response. I go through all the characters and all the digits, capital letters, and everything gives me a fast response back. What does that mean? That means, yeah, there are no more characters to look for in this password. So the stopping condition is that if I have a password of, so this is length 8, where I get that sleep, and I tried all the passwords of length 9, and none of them sleep 5 seconds, then I know Bob's password is likely just password. Or I could just check, I could drop the % off of this query. In fact, I could do this up front. I could drop the % first to see, am I done? Like I got 8 characters, let's just try password on itself. And then if I can get it, if I sleep 5 seconds, I'm done. I know Bob's password. So when you write your program for your blind SQL injection program, you're going to need a stopping condition. And that would be where you actually test rather than you get rid of all the wildcards and you test that one string. And if it gives you the result, then you're in. Okay. Other questions about what's going on with this? The binary keyword, what is that for? It is an encoding keyword for SQL that I'm not going to cover necessarily, but it's something on the back end. That's a detail in the back end SQL. Yeah, strings. Yeah, it doesn't like. In fact, there are other keywords there that are not listed, but this is a back end database thing. So yeah. Okay. One of the things that you saw with this is that I'm linearly searching every single character. That's really inefficient, right? Like every single character of Bob's password is a query against some server. That server is going to look at all this querying coming from you and be like, I got to shut that down. In fact, good web application firewalls will see that activity and try and shut that down quickly. So you want to minimize the number of queries that you send to the back end. And this is where the regular expression comes in, because I can do a binary search on the ranges of characters in order to zero in on the character that it matches. Okay? So for an example, this is a CTF Natus. It's a web security CTF. This particular level has a interface that checks to see if a user exists. I was going to show you a demo, except they changed all the passwords for all the levels. So I had a direct link that showed the interface, but now I have to redo all 15 levels in order to show this to you again, which I didn't do, unfortunately. But trust me, this web interface, if you can use your imagination, has just a single form, and it has a user field, and it says, does this user exist or not? And if you type Natus 16, if you type foo and click, it'll say user doesn't exist. If you type Natus 16 and hit click, it says user exists. Natus 16 with a single quote says, returns user does not exist. So it doesn't break the query. So this means that they weren't using single quotes to delineate the string. So it's not injectable with a single quote. Natus 16 with a double quote breaks the query. And then you know, okay, it was double quoted, the SQL statement was double quoted, and by injecting a double quote, I broke syntax. And then if you do this double quote, and then you do or 1 is equal to 1, it says user exists. So this sequence was to show you how you can now inject into the SQL statement that runs the backend. And you could similarly put this double quote with the comment character, and it would say user exists. So I'm going to show you the actual PHP code that implements this level. So on the back end, there is a table, and it's got username and password, and that's in the comments at the top. So 64-character username, 64-character password, and this is the PHP that implements the form. And you see the query is double quoted, select star from users, where username is whatever is supplied in the request, the username request parameter, HTTP request parameter. And then I'm going to take that and I'm going to issue the MySQL query, and if the number of rows is greater than 0, I say the user exists. Otherwise, I say the user doesn't exist. Otherwise, there's an error in the query, and so if I don't close syntax, that's the error I get back. Okay, so that's the actual form that you're injecting into. And so with this, you can apply a blind SQL injection attack to get at Natus16's password. So that's the idea. You know Natus16 exists. Now you want to apply SQL predicates in order to pull out Natus16's password. And once you figure that out, that gets you to the next level. That allows you to progress to Natus16. Okay, and I wish this worked so I could show it to you as a demo, but this is what we're going to do. So we are interested in Natus16's password. The password will say, just for simplicity, are the digits 0 through 9, the capital letters, and the lowercase letters. And I want to show you this as a big range because I want to show you how we're going to use binary search to zero in on the first character of this password. So typically you would need log n queries in order to zero in on the first character rather than order n. And so for your program, you should be implementing a binary search tree in order to get this. Initially, you could do a linear search just to make sure you can get something working. But when the TA is going to grade your program, he's going to look for binary searching to be implemented. But incrementally, I would suggest you could starting with the linear search in your program. Okay, so this is the search range. So let's just assume that all the password characters are in this set. The first thing you would do is inject this username. So Natus16, I break syntax, and then I say, and password matches this regex. And it says, begin with any of these characters. So I'm going to take the first half of this range, and I'm going to see whether or not the password matches that regular expression, and I'll receive back from the interface the user doesn't exist. So what this means is that the character is in the second half of the range, starting with capital V up here, all the way to the right to little z. And so what I'm going to do is now I know to search the other half, and I don't need to search the other half entirely because I know the user, it's going to exist somewhere there, so I can take the first half of the remaining range and search that. And that's what your next query should do. Your next query should take the first half of the resulting range, which goes to little j, and search the user for that. So this is what this expression does, regex hat v through little j, and it says the user exists. So now you know the first character of that password is in that range. You can cut that range in half and search the remaining part of that. So the next query is searching capital V to little b. And then this gives you that this user exists. So then you search the first half again. V, W, and X, the user exists. So it's an odd number. So let me just say I search for whether this password begins with a capital V and the user doesn't exist. So then I'm going to search for the first half of the remaining, which is W and X, and this user exists. Now here I have a single character that it's matching against, so I know that the password begins with a capital W. Okay. Once I know it begins with a letter, I can go on to the next character. So the next query will be this. It begins with a capital W, and then I repeat the search again. I go 0 through capital U, so the first half of this search list. The user doesn't exist, so then it's just like in the previous example, I go to the first half of the remaining the user exists, I go to the first half of that, and I keep on going in a similar way, and I get to a point where I'm searching this range, Y, Z, A, B, C. I take the first half of that, it doesn't exist. I take a first half of the remaining, which is little a, and this user exists, and then I can get a second character off of that password. Okay, are there questions about the algorithm? Yeah. So the question is, we're dividing the list into 3 parts. We're actually dividing it into 2 parts. It's a logarithmic algorithm where we're having the search space every single time, is the idea. Yeah. Okay.
How do we know which side to choose as far as which half? How are we getting closer?
So how do we know which side to choose is the question. So you will know based on what you receive back.
Oh, I see. Now, so the second query, the user exists, so we know that it's somewhere in there.
Yeah. So if you
take half of that, and it gives us what we need to know, basically.
yes. So what you get back will determine the next step of your algorithm.
Which side?
Which side? So you have to parse the response. And I have code in there to parse the response for your homework. I'll show you that in a second. But yes, it's really important for you to be able to, for example, on this, you're parsing whatever information you can get back from the web app. If the web app is going to give you differentiated results back based on something that you injected in SQL, then you need to parse that output in order to figure out what your algorithm is going to do next. And in this case, you have 2 different strings, whether it exists or doesn't exist. So you can use the doesn't keyword. You could search for doesn't in the output, and then that will determine which half to search on as your program. Yes? That's a good question. So the question was, are the queries always going to be single quotes or double quotes? I believe most programming languages will encode strings with single quotes or double quotes. Python does the triple single quote and the triple double quote as well. So if you are doing this kind of injection into a string, those are the only string delimiters I know of. But yeah. I don't do a lot of these, so yes. So the question is, do we have to take into account special characters? In your program, no. In the real world, probably. And in fact, in the real world, you have to deal with character sets. And I didn't show this to you here, but you have to specify the character set you're searching into in SQL. So similar to this binary question. Yeah, in order to do the ordering. But that's beyond that level of detail. Unless you're actually doing this for a living, is not necessary. I just wanted you to see and get the feel for injecting into the back end on that. But that's a good question. Yep. Yes, so the question is, can we assume it's all ASCII? Yes. Yes, please assume all ASCII. In fact, maybe not on this one, on the other one, it's going to be all alphanumeric. So yeah, it's like it's just a proof of concept rather than an exhaustive thing. Yes.
In the real world, you get password locked out pretty fast.
What was the?
Did you get like password locked out if you're trial and error guessing?
Oh, so yeah, the question is, would you get locked out if you're pointing this at a real site? Yes, you would hopefully get locked out, but obviously it depends on what is the operational security of the target property that might be being attacked. So hopefully there are controls in place, but you would be surprised. So this is why things like web application firewalls are being sold, because if you have somebody terminating the request, seeing these naughty strings go by and saying, I'm not going to pass you along to the actual server, that's where the value add of some of these products are. And I think like Cloudflare will do this, and Barracuda Networks. I think they have a local thing here. That's the kind of stuff they do. They send you, they allow you to deploy something up front, so it's never hitting the database. The site it's terminating up front before your server, looking for those kinds of search strings, injections, and then just getting rid of them. And so one of the things, actually at the very end of this class, in the tools, you'll be running in fact, there's a lot of tools to do SQL injection, to automatically test for SQL vulnerabilities. One of the most popular ones is SQL map. And so what you would do, what you should do as a developer is be running SQL map against your backend or your web property every night to make sure that it passes. Because SQL map will try and automatically send a bunch of these strings through to your web forms and then figure out if any of them are injectable. So it's more of a software assurance thing now, hopefully. Hopefully you don't see many real injections in the wild, but you never know. Yeah, it is still the #1 vulnerability in OWASP. So, any other questions about this algorithm? Okay. Okay, so then I'm going to go talk about your program. Write a program that leverages SQL injection in MongoDB to find the password for the account admin. In this one, it's easier because the injection is done in the HTTP GET parameter. So all you're doing is handling URLs to do this attack. You're going to do a binary search on alphanumeric characters. So the password that you're going to search against are just numbers and letters. And then I'm going to have you use Python with requests and then the beautiful soup for parsing. And I'm going to give you the template program that does that, so you don't even have to learn beautiful soup if you don't want to. So here is the regular expression that matches all passwords. This .password.match, it begins with any character and has any number of those characters. All right, so that's true on everything. So the first thing I want you to do is when you bring up, this is Web for Pentester 2, and this is MongoDB example 1, I think. And so what you do is in this MongoDB example, there is a form that allows you to search for a user and whether or not that user exists. And so instead of searching for just admin, I'm going to break MongoDB syntax, so it was using a string that was single quote delimited. So you're going to break the syntax on that, and you're going to use the predicate. And we talked about how the predicate for MongoDB is slightly different. So rather than the keyword and, it's the double and. And then when you do this, you should get that the admin exists, right? Because the admin is there already, and then you're saying, does it have a password? And it's like, yeah, it's got a password, so that'll exist. So I have this up. Oh, so it's MongoDB example 2. So on mine, I click on that. So let me see. Let me show you what this looks like to begin with. This is what. I guess so. This is search for admin, and this returns all of the users with the admin account. And so if I inject a single quote, you see that there's a compile error that gets returned. So this is where I know I added a single quote at the end of admin. It gave me an error. This is what tells me it's injectable. So then this URL, when I click on this, one of the things that you have to do is that you have to URL encode your exploit, right? Because if you look at this, statement, this statement has a bunch of slashes in it. URLs with slashes get parsed as directories in HTTP. And so if you don't want the web server to interpret the slash as a directory traversal, you have to URL encode it. And if you URL encode this payload, it looks like this thing. This is why all this craziness is here, because this is the URL encoded version of what you see up there as the search term. So in case you were wondering. And so here's another query. So you can sort of see the regular expression here is right here. So this is the slash URL encoded. This is the hat URL encoded, and then the dot star doesn't need to be URL encoded, and then followed by another URL encoded slash. So that's basically what this URL encodes into. And then here we've just modified this URL to search for the capital letters and the numbers 0 through 9. So I'll initiate another search by clicking that, and you'll see that the user disappears. So what does that mean? There wasn't a match. So this means the admin password doesn't begin with capital A through Z or 0 through 9. Because I asked that predicate, I put in my predicate that if the password matches A through Z 0 through 9 dot star, then return that. If that admin's password doesn't fall into any of these character ranges, it's going to eliminate that query, the row. So if I take the flip side of that and I say, okay, I'm going to search for little a through z, and I click on this, then you'll see from the interface that you'll get back the admin. Okay? So this is where you're able to now search for all the individual characters of the admin's password. Okay, so here's a template program that I want you to start with, and you'll see the programming assignment is basically a code lab where I scaffold you up to what I want you to have as a starting point. This is part of the scaffold, the starting point. And if you look at this Python program, it imports requests and sys, which is the system package. It imports beautiful soup. The reason why it needs the sys package is because it wants to pull as the first argument of your program the name or the IP address of your WFP2 site, right? All of us are going to have different IP addresses for WFP2. That should just be passed in. And actually, when we test your program, we're going to point you to a WFP2 site of our own that's got probably a different password than the passwords that you're using, like that are the default, and just to make sure that your program works on a variety of passwords, that you didn't just hard code. I don't even know what the password is, but we know what the password is on the default. We're going to make sure your program finds the other passwords too that we do. Yes.
Are we going to be able to test against different passwords?
Yes, and in fact, I'll post some instructions on how I'll tell you now, if you want to SSH into your WFP instance, the username is just in case. And so if you look at this, after I get the site, then this is a Python F string where I say I'm going to substitute the site in from that was defined earlier, and this is the URI. And then in this case, the injection hasn't been included yet. You're going to have to include the injection eventually. And so this will search for that. This is the default search, and then you do a request.get. You get the result in response, and the text of the response you will send to Beautiful Soup's HTML parser. And then from soup, you can issue the find to find all the table elements in the HTML. And so the result is included in a table that's got this admin string in it. Like if you remember the UI, I'll show you the UI. This is a table, and in this table, it's got an element admin, and that's what this program is doing. Oh, geez, I lost my place. No. It's just finding admin in one of these, in the text field of one of these elements. Okay, so that's just a simple test to see whether admin is still there. This is what I want your program to output to look like. So you're going to name your program BlindSQL.py, and it's going to be in the a particular directory that we'll show you. You give it a site name, and in this case, I'm running it on localhost on port 8000. The first search term, you'll see that it will look for 0 through 9 in the capital letters. And you'll see that there's no match here. So as with the Natus levels, if there's no match on this end, then you go to the other end, take the first half of the other end, and then it matched, so then you take the first half of the match. This doesn't match, so then you search the other half, the first half of the other side, and then the first half of the other side, C, D, E, and F, is no match. So then you're going to search GH on the other, the rest of that range. And then GH doesn't match, so then the other half is IJ now. So you can search for I, and I matches. So then you know that the first letter of admin's password is I. And this is the default in WFP2. So if you are running your algorithm and the first character isn't an I, you got something incorrect in your program. Okay, but your binary searching should look like this. It should eventually only take you, what is that, 6 queries to figure out that the first letter is I. Now initially you could take all 50-some, 62, you do them one at a time before you implement your binary search, just to get a sanity check that you know how to get things to and from the form. So you could do that first and then do the binary searching. In fact, incrementally, that's what I would do, because if you commit code that shows a linear search, we'll give you partial credit for sure, right? But if your code just completely doesn't work and we don't know how far you got, then yeah, that's not good. So yeah, have a version in there that you can roll back to as a backup. Okay, and then as before, after you find the first character, you continue with that. So then your next search will be the hat I, and then you'll search for the next character in a similar way. Okay. Some just notes on the program. Derive the program from the initial script that we just gave you. Name the file as instructed in the code lab. This is to help the TA uniformly grade your assignments. Continue until the password is found, and make sure that you have a terminating condition so that your program can end appropriately. And then the program submission is done via Git through your repository. And then there's a rubric that's described in the code lab for the things that we want you to do with your program. So things like good software engineering practice, like in terms of commenting making your code modular, commenting things, these sorts of practices that we would like you to add into your program, just to help you with those development skills. Okay, so that is all I'm going to cover today, and the rest of the time I'm going to help you hopefully with your SQL stuff. You can get started on this Blind SQL program. I'll leave it up to you. Okay. I'm gonna. It's in the code lab.